All right, and we are live. Welcome. Excuse me. Appreciate everybody being here. In case you don't know me, my name is Chris Musel. I'm one of the owners of Coldbreak. We've been manufacturing and selling portable draft equipment for going on 13 or 14 years now. So we are excited to have everybody here today. Appreciate you being here. Today we're going to focus on the intro to draft systems and their components. So basically, we're going to break down the draft system to each and every part. We'll talk a little bit about it, talk about the nuances between each of them, and then we'll bring all of that together tomorrow, where we ensure a quality beer pour. We'll talk about the three main types of draft systems: long draw, direct draw, and then the temporary draft systems like a jockey box. Then on Friday, what we're going to do is we've invited Myron Tan up from Virginia, and he's going to bring up one of his trailers. But we will do a in-studio interview with him, and he'll talk about how he builds his trailers, and hopefully you guys can get some good information that way as well. So today, a couple housekeeping things. First thing, if you guys have any questions along the way, the easiest for me, stand by here. Easiest for me would be to put a Q in front of your question. That way I can filter it. I just posted how to do that, and then I can bring that question up on the screen once you've asked it. So let's get into today. So today we'll do a system overview. We'll talk about what a draft system is, and then we'll break that down into its three main components, which is going to be the gas side, the beer side, and then the cooling side. And then within each of those, we'll talk about the specific gases you can use, the types of regulators, the different types of beer couplers, the many types of beer kegs, the many types of beer line, and then finally we'll talk about the different types of beer faucets. And at the very end, I will kind of go over the long draw and short draw, direct draw draft systems again, and hopefully by then you'll have a better understanding of the parts and pieces that go into it. All right, so how does my beer get out? This is displaying a jockey box. So one of the three, whether it's the long, direct, or jockey box, the temporary setup. But we're going to focus everything beyond that from here, right? So CO2 is always attached to a primary regulator. The regulator feeds the keg. The CO2 pushes down on the beer. The beer then goes up in the middle through the keg spear and out through the beer coupler, and then either into a temporary draft system like a jockey box, or it will go into another type of system, which would be more like a long draw draft system. So here we have the same types of setup. So we've got gas feeding to the keg. The keg then the gas pushes down on the keg. The beer goes up through the keg into the beer line and then into the main trunk line. So the trunk line here would be a glycol, or this one's air chilled system that goes into barrier tubing. The barrier tubing, or the tubing that you would see in a jockey box, would be either a coil or a cold plate. And then it ultimately winds up at the beer faucet. So that's kind of like a brief overview, and let's get into the nuances of gas. So dispensing gas is usually made up of CO2. A brief overview of beer. Today we're going to be very beer specific, but that doesn't necessarily mean you have to use your draft system for beer specifically, but because of carbonates the beer, so we want to use that same gas because it's not going to affect the flavor of the beer itself. So when we talk about how we all probably learned how to get beer from a keg is with the hand pumps that you attach to it, and you're forcing air into the keg. We don't want to do that because our breathable air is comprised up of 78% nitrogen, 21% oxygen, 1% argon, and 0.5% of CO2, along with a couple other smaller things in there as well. But the biggest thing here is the oxygen, right? Because it's such a strong oxidizer. As soon as oxygen comes into contact with beer, it starts changing the flavor, and within about an hour or two, your beer ends up tasting like cardboard. So if you're a professional and you're trying to get the beer out of a keg, serving in a professional manner, you don't want oxygen anywhere near or inside of the keg. So we're going to do everything that we can to keep it from entering the keg. The other gas that we can use is nitrogen because, again, it's an inert gas. It won't affect the flavor of the beer. But if you're pouring straight nitrogen, what happens is the CO2 eventually comes out of suspension in the beer and then it will go flat. So we'll get into the nuances of carbonation and that tomorrow, but just know that you can either use CO2 or you can use nitrogen, or what a lot of people will do is they'll use what's called beer gas, which is a nitrogen CO2 mix. And that mix and the percentages will depend on how long your draft line is, the resistance in your draft line, and what type of beer you're pouring. So the other thing we'll talk about is, I guess we'll talk about today, safety. CO2, nitrogen, and argon are both heavier than air. So when we're using CO2, especially in enclosed spaces, either like a draft trailer, a kegerator, a keezer, if there's a leak anywhere, it can asphyxiate you. So we just need to be careful. A lot of places will include CO2 monitors CO2 alarms that will go off in case there's an overabundance of CO2 or nitrogen in the area. And then if we go back, let's see here. You'll notice here in this long draw draft system, they are using a mix of CO2 and nitrogen, and this is what's that's a gas mixer. And so if you're pouring a beer that's like 60% CO2 and 40% nitrogen, what this will do is it will mix it for you rather than having nitrogen and CO2 into one tank. So when you purchase beer gas, typically you'll find nitrogen and CO2 inside that tank. The downside to doing that is with CO2, you can compress a lot of CO2 into like a 5-pound tank, a smaller tank. And at a certain temperature, that CO2 will turn into liquid. That same amount of nitrogen takes an extreme amount of pressure to get all of that same amount of nitrogen into that you could get into a CO2 tank. It operates at a higher temperature. So CO2 and nitrogen don't typically like to mix very well. And so when you do add them together and you put them into its own 5-pound tank, what you wind up getting is like a tank that can only dispense one keg of beer, because there's just not a lot of gas inside of that tank, because the way that CO2 and nitrogen operate together, the CO2 will turn to liquid before the nitrogen can. And so anyway, there's some nuances in there that we'll get into a little bit more tomorrow about. But yeah, so when you leave the CO2 tank, what we wind up connecting to would be, nope, that's couplers. We're going to go jumping ahead here. We're jumping into regulators. So from the CO2 tank, we attach a regulator. So the ones that are red here are called primary regulators because they attach directly to the CO2 tank. Below that, we are what's called secondary regulators. They look almost identical, but you'll notice that these ones have barbs on the end of it, and they don't attach to a CO2 tank or a nitrogen tank. So you can connect a primary regulator. So this one would connect to the CO2 tank, and then this one you could run the gas out of here at a higher rate, and then once you get down to your secondary regulator, you can connect the two with a tubing, and then you can dial in your keg from here. And you can connect these into a series like this. You can either have one or you can have it 4. The backs of the primary regulators will have, let me go here. Let me go to my overhead cam. So one of the things that you'll notice is on the back of some regulators, There'll either be a PRV valve like this, or sometimes you'll see it, depending on the manufacturer, it will kind of come out the corner here as another valve that you can pull that will also relieve some pressure. But this is a safety valve that will pop. Typically what we've seen is about 52, 53 PSI. Is if you go too high on the gauges here, what will end up happening is this will just open and then all your gas will just start escaping the back. So one of the things, if you ever turn your regulator on and you just got a bunch of gas coming out the back of it, it's your pressure relief valve that went off, and just lowering the pressure will turn that back off. On these tap right regulators that we sell, the main knob here, there's different, I only brought one, but there are different ways. This is a nitrogen regulator, but the top's either going to have a screw to adjust the pressure, or it's going to have a giant knob, or there's a hybrid between these two, which has a knob that you don't need a screwdriver for, but it just has like a T handle on it that you can move and adjust the pressure. So, but we like the big tap right ones because you don't need a tool to adjust the pressure. But one of the downsides here is these come locked. What a lot of people don't realize is that when you have to pull it out in order to move the dial, move the gauge. So these primary regulators come with two gauges. One of them is a fill gauge. It will show you basically that it's full, and it will stay full basically up until it's almost empty, and then it will show empty. One of the ways that we like to tell people is, if you really want to know how much CO2 is in your tank, you need to weigh it, right? There's a tare weight that's usually on the CO2 tank, and then once you fill it, they're 5 pound. If they're a 5 or 10 pound tank, subtract the tare weight from whatever it weighs, and that gives you the amount of CO2 that you have. The other one is the pressure gauge. 0 to 60 is all you need. You really won't go above 60 because, again, these will pop at like 52, 55, somewhere in there. And then same with like the beer couplers. Those have a pressure relief valve on them as well. And if those get too high, that pressure relief valve will pop. You can buy these with higher higher PSI. So I think they go up to like 120 or 150. The problem with that is it's really hard to dial in how much PSI you need with a gauge that's higher. So we like the smaller ones. Also, when you're connecting it to the CO2 tank, there always has to be some sort. You never want metal on metal, right? So you always want some sort of washer between them. The tap right regulators that we sell have a built-in one. These will go bad. If they ever do, they also make nylon washers that can replace these as well. And if this ever does come out, it's kind of hard to tell, but this actually can unscrew with an Allen wrench. And then at the very bottom here, it's got a cutoff check valve on it. So in case you just want to shut the gas off from here rather than at the tank or turning the gas all the way down. So that's a primary regulator. Let's go to a nitrogen regulator. So what you'll notice is that they are different connections, right? This is a CGA 320 connection. I don't know the technical name for this one off the top of my head, but you know that one is male, one's female. Nitrogen runs at a lot higher pressure, so they're just different. This also has a built-in washer on it, but otherwise they function relatively the same, right? We've got a check valve, we've got a fill gauge, we've got a PSI gauge, and then again on the back of it, we've got a PRV valve. So this would be a secondary regulator. Let's see if I can get it in the center of the screen. This would be a secondary regulator. And what you can do is attach one to the other like that. Run this at a little bit higher than you normally would. And then you can dial in. These would feed the kegs this way. The back of our tap right regulators also have a threaded hole in it. So you can either attach a bracket, or what we like on the primary regulators is they have a cage that you can put on these that goes over it. Because once these go onto a 5-pound tank, they can get kind of tippy, and the gauges have a tendency to break or bend. So we like having these covered with gauges, or excuse me, covered with a cage. apologies, 1 second here. We were at regulators. All right, so once we leave the the mini regulators. So relatively new on the market are some mini regulators that you can either, let me go back to the overhead view here. Are mini regulators that you can attach larger CO2 tanks to. Whenever you buy a nitrogen or CO2 tank, they're never going to come full. They, by law, like you can't ship CO2. So this is the largest CO2 tank that you can ship by law that's got CO2 in it. So these are 74-gram CO2 tanks that will feed mini regulators. They attach through a threaded neck on them right to the bottom, and they act very similar. So if you're just dispensing one keg, these are a good way to go. They also come in nitrogen. These will last, like if you're like, we have these little 2-gallon kegs that we can dispense with these, especially if you're making like batched cocktails. You can get 3 or 4 kegs out of one CO2 tank. But again, with the nitrogen, because it's such a higher, you need such a higher pressure for them, you can't get as much nitrogen into these little tanks. So you get about a 1 keg with these, and they're a little bit more expensive. So we like using CO2. Any questions on regulators before I move on? All right. Sorry, I lost my place here. Regulators, couplers. Here we go. All right, beer coupler. So we go from the regulator to the coupler. And what we're going to see here is a typical US keg needs a Sankey D coupler to it. There's different types. There's D, there's S, there's U, there's A. There's a bunch of other letters in there too. But the Sankey D is the most common. They all work relatively the same way, which is there's basically a probe down the middle of this that the lever pushes down onto the keg, and that opens up the keg. Whenever you buy a beer coupler, this probe here that's in the middle of the keg needs to be made of stainless steel. So don't buy one that's chrome plated. That chrome plating will eventually wear off, and it will impart metallic flavors into anything that you pour out of it. So when you're buying parts, make sure you're buying quality. Same with the tailpieces. You want those made out of stainless steel because that's actually touching the liquid as well. The beer nuts don't need to be made of stainless steel because they don't touch it. All they're doing is attaching the tailpieces to the probe. Sankey S is a Euro type. The difference, it's hard to tell just from looking at them, but the only difference between a Sankey S and a Sankey D is actually the length of the probe. So Sankey S's, the probe goes down a little bit farther into the keg. U is for nitro, and then A is like a German. So this would be like a Guinness tap, and then A would be more of like German beers or import beers. There are also people out there that have corny kegs, mainly home brewers or people that are batch cocktailing. The black is for the liquid side. The white is for the gas side. And let's take one apart. All right, so I got a beer coupler in front of me here. The top part of a beer coupler is the liquid out. So the gas in is always going to come from the side. And when the gas goes in, what it should do is enter what's called a little check valve. So inside this regulator, you should be able to pull out a little check valve. It's like a little baffle that will open. So as air enters this, it opens up and allows air to go through it. Then if your gas ever runs out, what it does is it prevents beer from going back up into the coupler, and it prevents beer from going into your beer lines. So that needs to be in there. These are tailpieces. These come in different sizes depending on the size of your tubing. This is a hex beer nut. You don't. So anytime you have, like, in any draft system, it's all metal to metal connections. And anytime you've got that, you have to have some sort of rubber seal between any of these connections. So these are called beer washers. When you do buy something like a jockey box, it is a very good idea to always buy extra beer washers because these get lost very easily. I always like zip tying them to the inside of a jockey box. That way I've got extras. So you don't typically need a beer washer between your gas side and your gas tailpiece here because the check valve acts as its own beer washer. Down below, there's another washer because it's metal on metal. This one attaches to the keg. And then again, there's another washer in here that goes on. This is above the ball that you push down on the keg itself. So there's a couple other washers in here that will eventually fail. So these can be replaced easily. Again, it's a locking lever that basically when you pull out and push down, it moves that center probe down and it pushes down on the ball onto the keg, and I'll show you that here in a few minutes. So this is a Sankey D. It also has a PRV valve on it, which is a pressure relief valve. This will, again, usually go off at about 53 PSI, 52, 53. So if you ever have a bunch of air leaking out of here, your either keg pressure is too high or your too much gas pressure is going into it. So that's a D. One of the things that you can do to a D to go back and forth between your ball locks is you can add these adapters to the top and to the side. What this allows you to do is have maybe like if you're batch cocktailing, it'll allow you to use corny kegs and then to go quickly from your corny kegs to your Sankey D kegs. You're basically it's just attaching it here, and this would be to your gas line. It's fine for a temporary setup if you're going back and forth a lot. It'd probably be best to invest in something that's made out of metal. You know, they do make these in metal. They are more expensive, but these typically will fail eventually. We don't have much luck with these. So we used to do this, but we've kind of gotten away from it. And again, it also creates just another connection in your system. So the least amount of connections you can have, the better, just because there's so many in a beer setup that it just can create another leak point, right? So this can fail. Those balls in here can fail. The poppets can fail. The connection here can fail. That can fail. So there's just a lot of connections here. So if you can, rather than add all these connections to it and you can just go directly from your tubing to this, you're better off in the long run. But for temporary setup, or if you just need a quick connection, this is a good way to go, right? So that can connect to the top and then these to the side. Ball locks either come, let me put these to the side. Ball locks either come with what are called MFL fittings, which is what this is, or there's basically just a straight barb that comes off of these. The ones with the straight barb, I believe, only come in 1/4 inch, so you have to use 1/4 inch ID tubing for that. With these MFL ones that we like, you can actually swap these out for either 1/4 inch or 5/16. They might even make 3/8. I'm not sure, but we typically just carry 5/16 stuff. But this also allows you to, unhook it, and it's easier to disassemble your system. Like if this fails and you've got a backup, it's easier just to unscrew this and then add the next one on top of it. So, one easy way to keep your couplers clean is we like these coupler cleaning caps. We'll get into this when we actually do the cleaning part at the end of tomorrow, but these just lock onto your Sankey D couplers. And it keeps them clean if you're out in the field, but also at the end of the day, you can actually just engage this. You can untap your keg, engage this, and what it does is it makes a connection between your gas and your liquid, and it will force gas through your system. And so if you're using a jockey box, it will purge your system this way, just by connecting and closing this off. So. And then this would be a nitro. So this is a U, I believe. Same type of thing. You've got a stainless steel probe connection, and when it connects to the keg, you pull out and push down on the handle. It pushes a probe down, and it lets the beer into the coupler. So just a, same type of thing, just a different way, just a different connection. But Sankey Ds are standard in the U.S. All right, so Jeff has a question here. What is the average lifespan of a beer washer? It's not long in our world because we always wind up losing them. They should last you quite a while, though. I don't know the correct answer to that, but yeah, just have extras. They're cheap enough that if it looks bad, just pitch it. All right. So once we go from the couplers, the next would be, let me see if I got it all. Bollock, Sankey, okay, got it all. We come down here to the kegs. So these are all Sankey D connections on top, except for the corny keg. Again, these use the ball lock connections, the black and white ball locks. So one will go on this post, the other will go on this post. So basically, one side has a tube that goes all the way down to the bottom, which is the liquid side. And then the gas would connect over here, and it would feed the top of the keg and push down on the liquid that's inside of it. And then the tube that's connected to here that goes all the way down to the bottom, the liquid inside would come out through the liquid side. Half barrels are the most common. It's called a half barrel because a full barrel is 31 gallons. It's just a standard of measurement, and when it comes to a brewery, most of the time they talk about, well, what's the barrel size of their system, whether it's a 7 barrel or 10 barrel, which means that they're making 7 or 10 barrels of beer in a batch at the same time. So a half barrel is 15.5 gallons, and they weigh 160 pounds. So because of the size, it's easy to transport beer, but it's also kind of a pain because they weigh so much. If you're talking mobility, you want to be getting beer in quarter barrels or sixth barrels. Sixth barrels are hit or miss on whether the brewery actually kegs in those. You're mostly going to find slim quarter barrels, which are 7.5 gallons, and full, they weigh 90 pounds. The sixth barrels and corny kegs are relatively the same size. They hold 5 or just over 5 gallons, and they weigh between 50 and 60 pounds. Relatively new on the market are what's called Gregs that we have for sale. Gregs are 2-gallon kegs that are great for batch cocktailing, and the kegs that we sell have what are called threaded spears, which means you can unscrew the middle part here, the Sankey D part, and the whole spear inside of it can be removed. And our kegs have PRV valves on them as well to relieve the pressure inside of them. Most of these that you get commercially, they have a locking ring on the inside of it, and the spear is not meant to be removed at all by anybody in the field ever. So these can be really dangerous. So if you start pulling on those pins inside of here, like that keg, I've seen. We were at I think GABF one year, and we saw one of the spears leave one of the kegs, and it shot beer up to the ceiling in one of the convention centers. So they can be quite deadly. These are meant to be cleaned by caustic, by machines, so they're not meant to be opened by people unless you've got a threaded removable spear. So just a word of caution there. And then here we've got the number of 12-ounce glasses that are inside of them, 21 all the way up to 165 beers per keg. There's also dimensions on here. So from the keg, then we're going to go up through the coupler because the gas is feeding and pushing down on the keg, the liquid that's inside of the keg, and the liquid's going up through the spear to the coupler again, and then out to what would be tubing. So there's 3 types of tubing. The main tubing coming off of your coupler is going to be what's called your jumper. So the jumper connects to typically barrier tubing, and then the barrier tubing connects to choker line. These lines are usually made out of different materials. Vinyl is the most common for jumper lines because it's soft, it's flexible, it's easy to maneuver. That's typically connected to barrier tubing, especially in like in a long draw system. Barrier tubing is very hard, rigid plastic and has a very low resistance. And so you can push beer through here at a great distance with very little resistance. There's also polyethylene tubing, stainless steel tubing, which you're going to find inside of a jockey box. And then there's also like high temperature silicone. So there's different kinds. But what you're going to see mainly is vinyl tubing, especially in temporary setups. There are different colors of vinyl tubing. You'll usually see red or blue or black for the gas side. And then we like clear on the liquid side because you can actually see how clean your lines are. So if you're using a jockey box or you're using, if you're in a direct draw situation where your kegs are attached inside of a kegerator, if you've got mold growth, you can see it, right? The only time that you would use colored tubing outside or out in the field would be to prevent light strike on the beer, and you'll see that in like a jockey box setup. But again, while it's good for preventing light strike, because you're using it over and over and over again, if somebody doesn't clean it, you're going to know right away. So we here at Coldbreak typically just use blue or red tubing for the gas side, and then we always use clear on the beer side just because we like seeing how clean it is. Tubing can be cut, and once you cut it, you can attach all kinds of different fittings to it, typically called tailpieces. So they can you can cut your tubing to length, attach tailpieces, which go inside of a beer nut, which then uses a beer washer between your connections. And this is what it looks like when all three of these are kind of stacked together. And then tubing is labeled by ID and OD, which is internal diameter and outside diameter. Now, depending on where you're shopping, different companies are going to label the product page different ways. And so it can be kind of confusing, especially when you're trying to build a system. So we, especially at Coldbreak here, everything is labeled by the ID. So if we label a tailpiece 5/16, it works with a 5/16 ID tubing. So example would be 5/16 ID, 7/16 OD beverage grade tubing. So if you're buying that type of tubing, you need a 5/16 tailpiece to connect to that tubing. So I do have a piece of vinyl tubing here. So here we have our tailpiece. We have our beer nut, or our hex nut, beer nut, which then pushes onto your tubing. And then in order to attach that tubing to the tailpiece, you're either going to use an Oetiker clamp, which is like a stepless clamp, which you need a special tool to pinch, and is more of a permanent installation. Or you have you can use a worm clamp, which can be tightened and loosened with a screwdriver. There's two types of clamps that you can buy. Oetiker clamps, one of the brand names is Oetiker. They're good stepless clamps. They're all sized differently. Like this is a 15.5, and they've got, depending on the size, that number changes, which would match the tubing size here. The other thing that you can do rather than a hex nut is you can need another tailpiece here. Is you can use a wing nut, right? So if you're doing more of a temporary setup, a lot of times you can add wing nuts to the end of your tailpiece rather than using a tool or a crescent wrench to tighten down your nuts here. You can also use a wing nut, which you can hand tighten as well. So we like wing nuts too on a lot of our stuff. All right. Sorry, let me find my spot here again. tubing. We talked about tubings, then we got into fittings. And again, each connection is going to need a beer washer as well. Anybody have any questions so far? Annette, let's see. Annette's question is, do you have any suggestions for keeping these cold for a mobile bar setting without a kegerator? I probably went past what you're talking about. Are you talking about the kegs? So that's a good question, and that is something that we fight with every beer event that we do. If you're starting with cold kegs, using a jockey box in a temporary setup, if you start with a cold keg, you don't typically need to chill it, right? So in ambient temperature, a keg will raise 1 degree Fahrenheit for about every hour. It's a little bit more than that, but you can kind of count on 1 degree every hour. So if you're only doing a 3 or 4 hour event, if your keg is starting at 36 degrees, if you can end it by the time it gets to 40 degrees, you should be fine, especially with a jockey box. It's leaving the keg and then it's going into your jockey box and cooling down. The CO2 really won't have much time to break out of suspension. But if you're in a really hot environment, if the keg's in direct sunlight, that keg is going to warm up extremely fast. And if your keg warms up at all, the CO2 is not going to want to stay in it. You're going to get foam pretty quickly. So we have these keg sleeves that we use that will surround them by ice. Buckets are a good way to do it. Lowe's and Home Depot have these like really big, like blue and red buckets that will fit a keg pretty easily. And just throwing some ice to the bottom of the keg, because the keg is going to empty from the bottom up, right? So the gas pushes down and the beer is being pulled from the bottom. So just icing the bottom of the keg can sometimes be pretty good. Okay, moving on. From the tubing, the very last part is going to be faucets. But in order to connect our faucets to the tubing, we use what are called shanks, right? So beer shanks, there's 2 types. They're going to be a faucet shank, or we call them rear shanks here because that's just what they were in jockey boxes, but they're, I think the technical name is coupling shanks. So you're most likely going to see a faucet shank. So the end of this tubing, let me see if I can go back to my overhead cam here. So if this is leaving the coupler with beer in it and it gets to the end, this thread, that it's the same threads that you would find at the top of any beer coupler. This thread is the same exact thread that you're going to find. Get back in here, man. Sorry, I didn't think it'd be that difficult to get back to where I was. Shanks. Nope, shanks. So this is a threaded shank, right? And so that thread is the same exact thread that's on the top of a beer coupler. So you can use the same beer hex nuts that you would use. So you have faucet shanks, rear shanks, and then whenever you're buying shanks, you always want to make sure that they're made of stainless steel. There are 2 types. You're going to find either stainless steel or chrome-plated brass. The chrome-plated brass shanks are a lot cheaper, especially if you're on a budget. But what happens is that chrome plating eventually wears off, because a beer, wine, anything you're going to pour out of there will be acidic, and it eventually eats away at it. And as soon as the brass is exposed, it creates a metallic, weird flavor. So you don't want that anywhere near your beer. And it's really porous, so it's really hard to get clean. So bacteria is going to wind up in your shanks, and it's going to be really difficult to get rid of it. So buy quality components. And so shanks offer a sturdy way to attach your beer faucets. So this is an example of I think a 4-inch shank. Go back to my overhead cam here. So we've got, this is a jockey box shank here. The difference between so this would be, let me jump back here. Going back to the rear coupling shank. So this is a rear coupling shank. So this is what we would put inside of a jockey box on the back of the cooler in order to allow beer to come into it. And then our coils would attach to here. So this is just a way for beer to enter the cooler by a nice stainless steel, very sanitary line here rather than using vinyl. So this would be just a really nice permanent way to do it. So again, if you wanted to attach your beer line to the back of a shank, again, this, screwed onto the top of a coupler. It also screws on to the end of the shank here. So this would be how beer would enter your shank wherever this is mounted. So you could mount this. You'll either see this in a tower. So towers have really tiny ones, and then it immediately goes down. You'll see these big ones, especially if you can put these into a walk-in cooler wall. So if you just drilled a hole into a walk-in cooler, you can sink one of these shanks into it and then connect your beer to the back of it. So this is a really nice, easy way to go through a wall. Or if you're connecting it to like a jockey or jumper box, you can have this externally, especially if you built like a mobile bar trailer that you have an exterior wall that you want to sink a bunch of shanks, and then you can connect your jockey box or jumper box to the back of this. This is a jockey box shank. It looks a little bit different. We always add these extension flanges on the side of it. What this does is it pulls the faucet out away from the cooler a little bit more. It's not threaded all the way through because we don't need it to be, because this is typically going to sit inside the cooler. So your cooler wall is going to be here. And then the other big difference is if you look on the inside of it, I don't know if you can tell, but these are drilled out a little bit. So this is a 5/16 bore that goes down into a 1/4 inch bore. So our stainless steel coils will fit right inside of this shank. And then the ID never changes. So the inside of our 5/16 coils is a 1/4 inch. So your beer stays the same ID all the way until it gets to the faucet. There are there are shanks that have the back like this. All of ours have these, so you can attach different size tailpieces to it. You can buy these where there's just a barb on the end of it, and so you can basically directly attach the tubing to this shank by the barb that's on it. So it's a hollow barb that would basically look like, let's see if I can get this off. So some shanks have this like permanently attached to it, and so really all you got to do is attach the tubing to it. So that's a way as well. So here's a quick example of what I'm talking about with the long 6-inch shank that I had in my hand. So this would be a long faucet shank going through a wall, which then would connect to some sort of tube, like a small shank jumper. Like you want this as short as possible, which would connect to either like a jumper box, or if this jumper box wasn't here, this could be a direct draw system where the beer leaving the keg, basically this tubing here, would go directly from here to your shank. And if this wasn't here and this blue area was a walk-in cooler and this was like your bar area, and so that way all of this is cold and this isn't necessary, this would be your faucet shank that was sunk into the wall here, and then it just goes to your beer coupler. Which brings us toward the end here, which would be standard with your beer faucets. This is a typical vented beer faucet. We deal with the standard beer faucets at Coldbreak mostly because they work really well in temporary setups like jockey boxes. They have a slower pour rate than some of the other ones down below it, so they work better. Again, you want to be conscious of material. if you look here, this is a standard beer faucet. Same with this. This is the same beer faucet, but there's one big difference. If you look at the very top here, this looks like stainless steel because it is. And this one down here looks like brass because it is. This means that the lever here is 100% brass, and it means there's brass down here as well. And so that usually means that this whole faucet is made from brass and then coated in chrome. So make sure you're buying nice stainless steel parts. And if you tear the standard beer faucet apart, you've got the shaft that's inside of it, which connects to your lever. It's connected to your lever by a bonnet here. This bonnet screws down and holds the lever in place. And then this collar up here is on top. This screws onto your lever as well. That way, in case you have a really large tap handle that you need to get straight, what you can do is tighten your tap handle as far down as you can, and then back it off so it's straight looking at you. And then what you can do is you screw this up to the tap handle and it'll hold it in place. So if you're ever to pull a beer faucet apart, which we can do here shortly, the two main pieces are going to be the shaft that sits inside of it and then the lever that connects to the shaft here. There's our other kinds. This is a flow control. You can adjust the flow. So if you're like, one of the good uses of a flow control faucet is if you were, let's say you had a small draft system and then you tapped a higher carbonated beer, but you didn't have really good control over the amount of PSI to each keg that you're tapping. What you can do is you can reduce you can restrict that flow at the tap, and that will help pour some highly carbonated beers. This is a ventless forward sealing faucet. I've got one here in the studio that I will tear apart as well, so you guys can see the difference between a vented and a ventless or forward sealing faucet. And then this is your nitro faucet. So this is a large, wonky faucet that as beer enters it and comes down, there's a plate in here that has 4 tiny holes in it. And what this faucet does is it forces that nitro beer into those really tiny holes and then comes out the spout. And what that does is it helps break out that nitrogen that's suspended in the nitro beer. And so if you ever look at a Guinness that's on the table and it looks like it's falling, that's the nitrogen kind of coming out of suspension, and that's in part due to the plate that's inside of beer that the beer is being forced through. So let's go back to my overhead cam here. And so here you've got a forward sealing and a standard faucet. These are going to be the two most common faucets that you're going to see. This is called vented because there's actually a tiny little hole in here. And so what that does is as your beer faucet closes, it helps the liquid that's inside here, just having that little hole helps it drain a lot faster. So these don't have any holes on them because they operate just slightly different. So once we pull the tap handle off, what you're left with is basically 3 large pieces. So you've got your lever, you've got your bonnet that's holding the lever on, which will pull off, and then your shaft will just drop out. So you'll notice that there's a ball on the back of the shaft with a tiny rubber seal. And so what happens is as you close the tap handle, what it does is it pulls this shaft to the back of the faucet where it seals, so the beer can't get any farther than that. So as you pull forward, that ball actually goes back and allows beer to go around it and through. Right. So the downside to this is if you've ever put one of these on your kegerator at home and you only pour beer out of it once every week or so, these can get relatively sticky, especially if you don't clean them very well, and they can actually stick shut. So these, on the other hand, these pour at a higher velocity, so we don't like using them on jockey boxes. But also you need enough pressure pushing forward because this acts kind of a little bit separate or a little bit differently because there's actually a ball on the end of the lever here. So once we remove the bonnet that's holding the lever on there, what we're going to see is a ball that's actually on the end of it. And what happens is when you open the tap, the ball moves away from the front. I don't know if you can see. like inside there, there's a gasket. And so when you open it, the ball comes away from that gasket and allows beer to go into it. And then when you close the tap, that ball pushes forward on that gasket and it seals itself right there. And so forward sealing faucets have a tendency to work better in kegerators, depending on the pressure that you're using, because that faucet shuts off the beer right here and there's not really room for beer to kind of like get sticky. So as you pull back on the faucet, that ball comes away from it. They work better in the kegerator setup. In every connection, there's going to be, in every metal on metal connection, there's going to be a gasket. Okay, so all faucets have a very tiny gasket on the end of it. So if you're ever getting leaks at your faucet shank, you're probably missing this little rubber gasket. There's that one, and then there's one on this one as well. So in a standard faucet, there's only one gasket. In a forward sealing faucet, if you ignore that one, because that one's kind of permanently installed in that, there's one on the inside, plus there's one at the back of the faucet where the faucet meets the faucet shank. All right, let's get back. Faucets. Oh, I do have a nitro faucet here. Sorry, let me go back. I think it's inside the... Yep. Okay, so it's inside the bottom part of the keg here. There's a tiny little... See that little plate in there? Oh, it's got 5 holes. I thought it had 4. So the faucet forces your nitro beer through that little plate, and that's what creates, the creaminess to it. And so nitro faucets pull all the way, when you open it up, when you're going to go pour a nitro beer, you want to pour it all the way down. And then most of them have a creamer ability. And so if you push back, you can push back a little bit on it, and it will allow a little bit of beer to come out, and it will create like a nice creamy head on it. I think that's all the toys I brought. Okay, so all right, I just dropped a link. If you want to join, if you guys have any questions, there's a bunch of you in here. If you have any questions along the way, you can use this link if you want to talk to me face to face. You don't have to, otherwise you can just throw a question up. But putting this all together, we've got the gas, which goes to a regulator, which feeds the gas line. This little white rectangle in here would be a gas filter, which feeds a manifold, which can take place of a secondary regulator set. A manifold would just be a block of aluminum that's got some switches on it, so that basically you can take one feed of air and divide it into 4. It's basically all it's doing. So then it's feeding 4 beer couplers, which is feeding 4 kegs, which the black lines coming out of here are your beer lines, which feed your shanks on the back of the faucet here. The faucet shanks are attached to the tower, and then you've got your beer faucet and then your beer faucet handle. Another system, this would be a long draw draft system. Again, you've got your gas. This is a gas mixture because it's going a long distance. We'll talk about that tomorrow. But it's feeding your gas lines, which are your red lines here, which is feeding your beer coupler to your kegs. Your liquid's coming out through the beer line. This is called a beer jumper, which then goes to your barrier tubing, which is called trunk line. And then sometimes it goes to a choker line, depending on the resistance, which would be vinyl tubing, which again, depending on the resistance, sometimes the barrier tubing would just be attached to the back of the shanks that are in this rectangular tower. And then you've got your beer faucets. So they're all relatively the same. And then if we go back all the way to the beginning, we do have a pretty good picture of, so this would be the same system, right? We've got your gas to the regulator, to the beer line, to the beer, to the coupler, to the beer jumper line, which then goes into your barrier tubing or trunk line, which in this case in a jockey box is stainless steel, which goes to a faucet shank, which then goes to a faucet. So they're all relatively the same. They're just set up just a little bit differently. Which kind of concludes today. Tomorrow, what we're going to talk about, we'll get into a little bit more detail about those systems, and we'll talk about beer carbonation. We'll talk about resistance. We'll talk about balancing kegerators. And then one of the biggest components of any of these systems is cleanliness. So we'll talk about cleaning. We'll talk about jockey boxes and jumper boxes a little bit and how to get the best pour from them. And so I'm going to open it up to questions. Fire them off if you can. Let's see here. Let's see. C asks, pros and cons of Greg versus Corny for batch cocktails. Corny kegs are easy to open. They have a very large space for you to work. They have a lot of moving parts to them. So each post has a poppet in it that can fail. There's separate connections for it. They were designed for the soda industry. That's where they came from, right? Coke and Pepsi used to use them. When they stopped using them and they went to the bagged and boxed, condensed syrup for dispensing soda, they got rid of all their corny kegs. And so mainly homebrewers picked them up. And so typically when you find them, they do sell new ones, but most of the ones on the market are used. They're all like made of stainless steel. Their parts are readily, easily accessible for the seals, tubes, and poppets and stuff like that. But there's just, I think homebrewers they use them to begin with and then realize how much kind of a pain in the butt they are, and then they'll eventually move into normal kegs or they'll go back to bottling. And I think as a professional, sticking with Sankey D connections, that's the standard in the industry. That's the easiest. It's going to give you the least amount of complications because they typically just work. And if I were to buy a bunch of kegs if I was starting a business and buying a bunch of kegs, I would just stick with Sankey D, and I would probably have an adapter available to go to a corny keg if I had to. Otherwise, I would just make somebody go to bring me whatever you have in a Sankey D connection. So we like the Gregs around here. We fill them all the time with water or batch cocktails or water making carbonated soda. We drink a lot of carbonated soda around the shop here. We just killed a keg of coffee. So we keg coffee. We use them a lot. So we like the threaded spears. They're easy to clean with caustic. So they're easy to keep. And we don't have to go back and forth between Sankey D and ball valves. So Annette asks, okay, so if I can get the bottom of the keg iced, that would help. Thank you for yes, you're welcome. Yeah, so really all you need to do is ice the bottom of the keg. A lot of times you'll see people that will throw a bag of ice on top of the keg. Well, that's nice, but you're really not doing anything because the gas is pushing down on the keg, and the first part of the keg that's going to empty is the top. So keep it down to the bottom. All right, any other questions out there? Oh, one more. Here we go. What are the benefits of a coil jocks versus over a cold plate? Okay, so the cold plate, the inside of a cold plate only has about 11 feet of stainless steel in it. So you're getting about 4 ounces of beer cold at once. While it's fine if you're grabbing a keg that is immediately coming out of a cooler and you're tapping it and you're your jockey box is full of ice, it's going to keep your beer cold. But if you're pouring more than a pint, like if you're serving samples, that's great. If you're pouring more than a sample and you're pouring pints or 12 ounces and it's a little bit warm, you're going to run into trouble. So you have to, with a cold plate, you have to ice your kegs. And you also have to keep the cooler drain open, which means that the cold plate always has to be in contact with ice, never ice water. And with a coil, the minimum is 50 feet that we sell around here, and that's pretty standard. That's like once you get to 75 or 100 feet, you're talking about an extreme amount of resistance, and you have to crank your PSI. So we like 50 feet. It's a really good median coil length to pour. It holds 17 ounces, so if you're pouring pints, you can pour a full one, and by the time that you've closed the tap and you hand the beer over or walk away, the next pint is pretty much ready and already cold. And as the ice melts, that little bit of water on the bottom can help. Ice will kind of tend to dam up around the coil. Like if this is the coil, and it, like as your ice starts to melt, the ice will kind of start to creep away from the coil, and ice, like the water, kind of helps keep that from happening. But it just really depends on your setup. If you're just, if you're pouring samples, they work fine. But if you really want to pour a beer, then 50 is a minimum. And then 100, 120 would be the max that you'd see in a jockey box, but that's overkill. If you're, at the Daytona 500 and you're pouring pitchers from a jockey box, then yeah, you're going to want something longer than a 50-foot coil, but 50 foot's fine. Any other questions? All right, well, we're at the 1 hour mark. That was my goal here, so I don't waste too much of you guys' time. I appreciate you guys joining us. If you have any questions along the way, please don't hesitate to contact me. Again, my name is Chris Musil. My email is up there. Also, we have a very strong support staff, so if you have any questions, fire them off at support@Coldbreak USA. You can find us on social media, coldbreakusa.com. And tomorrow, so we'll talk about the long draw draft systems, short draw draft systems, and temporary draft systems tomorrow. And then Friday, we'll talk with Myron Tan, who builds mobile trailers for a living. And yeah, we'll see you guys tomorrow. Thanks. Appreciate it.